Hi guys, today we're going to be talking about graphing linear inequalities. If you could please pause this video and try these two warm-up questions and then come back. I'll show you the answers to these two problems. Okay, here are the answers to these two problems. Notice that for the second one, you cannot just look at this equation and say that the slope is 3. You have to move it into slope-intercept form. Okay. Now let's go on to graphing the linear inequality. So here are, I've filled out the spots for you guys, so we'll talk about the steps that we need to do. First thing you want to do is write the inequality in slope-intercept form. This is important because we need to find what our slope is and what our y-intercept is. That's why graphing is super important for this. Step 2 is to determine the boundary line. This is new for you guys. If you have you want to draw a solid line. If you have any inequality symbol that has less than or equal to, or greater than or equal to, you want to use a dashed line for less than and greater than. This is kind of like the same idea when you guys had closed circles or solid circles and open circles when we were graphing just regular inequalities, but now we're actually going to be graphing them, so this is super important. The last step, or the third step, is to shade the solution set for the inequality. So you're going to be shading above and or below based on the inequality symbols. Notice how if it's above, you have to shade when it's greater than. So this is greater than or equal to. And the shading below is when you see the less than or equal to. I'll show you an example of it below here. Notice how you have two equations. One of them has this greater than symbol and this one has a less than symbol. Your line is a solid line because you have the equal to part, and now you can see based on what they're giving you, you're either going to be shading above the line or below. What I like to tell my students that kind of struggle with less than or greater than, with greater than symbols, you can actually make like a little G so that you know that you have to, that's a greater than symbol and you're going to be shading above your line. And then obviously, you know, from prior classes of this, you can have it look like an L for less than. Those are little tips that I used when I was in school, so hopefully that helps you guys out. And then the step 4 is check any coordinates that are in the shaded area by plugging them into the original inequality. So that's the basis for this topic. If you turn the page, we can start working on some examples. Okay, so as you notice, I like to highlight certain parts of my inequality so that I can see what each of them mean. The green highlighted portion is my slope. I already wrote down that my slope is -1/1, and my y-intercept is 3. Now, because I don't have an equal sign anymore, I have to do two things. 1, determine whether I have a solid or dashed line, and 2, I have to figure out, all right, am I going to be shading above or below based on my inequality? So I like to take notes here. Hopefully you guys write down exactly what I do so that you don't make any mistakes. So first things first, I see that I have a less than or equal to sign, so I'm going to be using a solid line. Make a note of that so that I don't forget. And I have a less than symbol, so that means I'm going to be shading below. Shade below the line. So I'm going to start by 0, 3. It's my y-intercept. My slope is -1/1, so I'm going to go down 1, right 1. Okay, and then continue the pattern on the other side. Now, this is the new thing that you're going to learn. Solid line. So I'm just going to connect all my dots. And I'm going to be shading below this line because I have a less than symbol, and anytime you see the word less than, you think of like smaller than. So all of basically saying y is less than any number on the right hand side. So all the numbers that are less than will fall under this line. So I'm going to shade that in. Okay. And if way to check to make sure that you did your work correctly, you can pick any point in this area and plug it into this equation so that you get a true statement. So I'll do that. I'm going to pick the ordered pair 0, 0 because that is part of the shaded area and that's a little bit easier for me to work with. So when I plug it into the original equation in here, I'm going to plug a 0 in for y and a 0 in for x. So hopefully I get a true statement. So here we go. Original problem is y is less than or equal to negative x plus 3. So if I substitute in 0 here and have less than, and I can't have a negative 0, so I know it's going to be 0, plus 3, I end up getting 0 is less than or equal to 3. That is a true statement, so that I know that this point is part of the shaded area, and I did it correctly. If you get a false statement and you shaded this area, then obviously you shaded the wrong area. This is just a way so that you can check your work. Okay. Go ahead and pause this video. I would like you guys to find the slope, the y-intercept, and take 2 notes here. Are you going to have a solid line? Are you going to have a dashed line? Are you going to be shading below or above? And then check in with me. Okay, so I've highlighted and wrote down what my 2 parts are. Slope is 1/2, b is 0, 2. Now, hopefully you guys have determined what type of line you have. You have a less or greater than symbol. Notice how you don't have that equal sign, so you can't use a solid line. You're going to have to use a dashed line. Okay, that shows that any point that's on that line cannot equal or cannot be part of the shaded area. It's kind of like the open circle concept. The shading part, now if you see this greater than symbol, remember my little trick of making a G? You know that you can shade anything that's greater than a number is always above, or it's going, like if you were looking at a linear line, like a line, all the numbers that are greater than are to the right. In this case, we're going to be shading above. Okay, so take a second to graph this equation or this linear inequality. Make sure you have dashed lines and you shade above. So I've plotted my points. Now I'm going to create a dashed line here. And I'm going to be shading above this number 2. Any number that's greater than 2 is going to be above. So then I'm going to shade that portion in. There you go. Okay. Next, we have some special cases. Remember, this is where we look at whether we're going to have a vertical line or a horizontal line. Hopefully you guys remember oi and boots. That is a way to help you out. In this case, y is less or greater than -1. So between these two, I'm going to be using the oi acronym to help me. Okay. So basically, h is a horizontal, 0 slope, and the y-intercept. That's what it's an acronym that helps you out. So in this case, I have a horizontal line, and I have the slope of 0. My y-intercept is this number right here. So I can write that down. b equals 0, -1. Now you have to determine whether you're going to be shading above or below, or what type of line you have. In this case, we have a dashed line because we do not have that equal sign, or equal to sign. And now we have to figure out where are you shading. So this one's maybe you're shading above or below. So here we go. I'm going to start at 0, -1. Based on my notes here, I have a dashed line because I don't have that equal to portion in my inequality. And I have a horizontal line. Now, back to the inequality. Notice how many times I go back here. You have to go back to the original equation just to make sure that you're figuring out the right parts. So this right here is a greater than sign. So that means I'm going to be shading above. So if you take this -1 into account, any number that's greater than -1 are all the numbers that fall above it. So this is where I'm going to be shading. Okay. Now, if you need extra help with this, let me know, and I can give you some extra practice. The second special case that we're going to have is when we have x is less than or equal to 3. Remember, we have oi and books. Whenever you have an x as your first number or your first letter, you can't take into account the oi because there is no x involved here. So erase this and fill in the different parts of this acronym. Oops. So when I have x and a number, I know that I'm going to have a vertical line. It's going to have an undefined slope, and what's given is my x-intercept. So this 3 right here, let me highlight it. This is not my y-intercept. This is my x-intercept. So I'm going to plot that point right there. And now I have to take notes. I'm going to figure out, do I have a dashed line? And am I shading? Well, this one's going to be a different example when we shade, because there's no above or below, and I'll show you in a second. So I have a solid line because I have the less than or equal to part. I have this part right here. Notice how this did not have it, so that's why we're having dashed lines here. So I have a solid line, and now I have to determine whether I'm shading above or below. But I want to show you something. If I were to plot this, write a solid line on this, you don't necessarily have any area to shade above or below. So when you have a vertical line, you're really going to be looking at whether you're going to be shading on the left side of the inequality or the right side. And it's the same idea of less than or greater than. You are reading this inequality and saying, okay, x is less than or equal to 3. So what are the numbers that are less than or equal to 3? Those numbers are 2, -1, or sorry, 2, 1, 0, -1, -2, all the numbers that are on the left-hand side. So that's where you're going to shade. There are those rare cases where you have to shade left or right, and that's only if you have a vertical line. So you have to know the difference between those two, okay? What I would like you to do now is try 5 and 6, and I want you to put them into slope-intercept form. I want you to find the slope, the y-intercept, determine whether you're going to have a solid or dashed line, and whether you're going to be shading above or below. Then check back with my video to see if you got the correct answer. Okay, here is my answer for number 5. I make sure that I had my answer in slope-intercept form, found the same information that we did above, and I determined that I have a dashed line because I have a greater than symbol, and then I shade above because it's all the numbers that are greater than 2. So that's all the way in the top. Okay. Number 6 is a very interesting one that I want to go over with you. So I want it in slope-intercept form, so I'm going to do that right now. I'm going to add x to both sides, and I'm going to go over on this side so I can give myself a little bit more room. So I have -1/2 y is greater than or equal to x plus 2. Now, in order for me to move this over, I can divide by -1/2 or multiply by -2, which is the reciprocal. Remember, reciprocal is when you flip the numerator and the denominator. So really, I'm going to be multiplying by negative 2 over 1 times negative 2 over 1 times negative 2 over 1 to every part of this. If you remember from solving inequalities, if you multiply or you divide by a negative number, you need to switch your inequality sign. Okay, let me repeat that again. If you multiply or divide by any negative number and you have an inequality symbol, you have to switch it. So in this case, if I multiply negative 2 to my left-hand side, I end up getting y by itself. So y is by itself, but because I multiplied by negative 2, my greater than symbol is now a less than symbol, and my slope is going to be negative 2x, and negative 2 times positive 2 gives me negative 4. You got to be very careful with these problems because remember, everything that you've learned before is going to be applied later. So this is the instance where you're going to be switching both your inequality symbols. Okay, and that's the most common mistake in this topic. From here, you can go ahead and graph, figure out what type of line you'll have and whether you're going to be shading above or below. Okay, this is the answer for number 6. Notice that I have a solid line and I'm shading below. The y-intercept was negative 4, so all the numbers that are less than negative 4 are below this line, so that's why I shaded this area, because eventually this line is continuous. It's going to touch all these negative 4, negative 6, all the numbers that are less than negative 4. Okay, so that's it with graphing. And now you will have some problems where you have to plug in x values to determine if it's part of the inequality. So basically you're trying to get answers that are true. Kind of like what we did up here. Let me shade this area for you. You're going to be doing this part, where you're going to be plugging in numbers and getting a true statement. That's how you know that the inequality is part of that solution. So I'm going to give you a few seconds to try to plug in some numbers and see what you think the correct answer is. Okay, so when we have this inequality, what I'm going to do is actually test every single point and plug it into here. This is a very popular question when you see an assessment or an SOL. They like these problems because there's always more than one answer. So I want to show you how to do this in your calculator. So I'm going to be plugging in for the first one. I'm testing 2 and 0. So this is my x value and this is my y value. I'm going to plug those numbers respectively into the correct letter. So this is how I'm going to do it on my calculator. So the original equation, let me just move this over so you can see, or not. Okay. I'm going to plug in, the first part is 4. So 4 times x. So I'm going to have my 4, include my parentheses, and substitute this 2 in for x. Okay. Then I'm going to minus 2 and whatever y is, which is 0. I'm going to substitute that in my equation at the same time. So minus 2 parentheses 0. This has to be greater than 3 in order for it to be part of the solution. So let's see. I have 8. So when I plug in my values, I get 8 is greater than 3. This is a true statement. So this is a solution. So I'll shade this in. Okay? So that's what we're looking for. True statements. Let me show you one where it doesn't work out, and that's the second one. I have x and I have y. I'm going to plug them into the equation. So I have negative 2 and negative 3. So let's go ahead and do that equation. 4 times my x value is negative 2. So I'm going to use my minus 2 x, plus, oh sorry, not plus, minus 2. And my y value is 3. So I'm going to put a 3 in there. Okay, and enter. I get negative 14. So if I go back to here, negative 14 is greater than 3. Notice how this is a false statement. That is not true. So I can't shade in those two, that particular point. So go ahead and try to figure out what the solution is. Make sure you hit a true statement and then check back with me so that I can show you the answers. Okay, so the two answers that work out, or the two other answers that work out is 100 and negative 20 and 4, 3/2. Okay, so those are your solutions. If you have any questions, please feel free to ask me in class, and good luck solving inequalities.